Unless I have to like put this on. Oh, I think I hear myself now. Okay, can you guys hear me? Oh, yeah, you can. Okay, so this is going to be really weird because there's like a 10-second delay. So between what I'm saying and what you guys can see, and oh, I need to clear off this screen. So awkward. Clear that. Even now, having a body of water in its last box seems like magic. The most common aquarium fish is the goldfish, domesticated in China more than 1,000 years ago. Okay, so I gave you guys, I emailed you two packets. One was like mechanics, and the other one was like electricity. So hopefully you guys looked at them and tried to do the questions. This is actually my first time looking at these questions. I found those questions online. Someone else created them. So this is gonna be my first time doing these questions or seeing them. I don't have a calculator. I don't have a protractor. I don't have a ruler, and I only have a reference table that's like online. So it's gonna be interesting. When you guys take the Regents, you'll have a ruler, a protractor, a calculator, and a reference table. No scrap paper. Okay, so let's do this first question here. This first question says, the weight of a chicken egg is most nearly equal to something. This is Fumi's favorite type of question. So the way I like to do these is convert these all into one single type of number. These are all like in scientific notation, and they're difficult to kind of understand. So I like to convert them into decimal form. So for A, for this one, 10 to the negative 3 would be 0.00123. Whoops. 1. Right? 1, 2, 3. Yeah. 10 to the negative 2 would be 0.01. 10 to the 0 is 1, and 10 to the 2 is 100. So which one of these is the closest to the weight of a chicken egg? It would be this one, 1 Newton. There's a simple conversion to remember. 1 pound equals, or is approximately equal to 0.25 pounds. I think it's, I mean, sorry, 0.25 newtons. That doesn't make any sense. So 1 pound equals a quarter of a newton. So a chicken egg is approximately 1 newton. That's the closest thing. 100 newtons, that's too heavy, and these are too light. These are like pennies or something. So someone says, I don't know who that person is, Moria Humiston says 1 Newton is about the weight of an apple. Yeah, that's true. It's also approximately the weight of a stick of butter. So if you can remember that it's the approximate weight of an apple, and then you think of what a chicken egg feels like, it feels like it's as heavy as an apple. Okay, let's move on to the next one. This one says, on a highway, a car is driven 80 kilometers during the first 1 hour of travel, 50 kilometers during the next half hour and 40 kilometers in the final half hour. What is the car's average speed for the entire trip? Okay, so excuse me. Average speed is like your total distance over your total time. So average speed equals your distance over time. So let's add up all of our distances. We have 80 kilometers plus 50 kilometers plus 40 kilometers. And we're dividing that by our total time. So our total time is 1 hour plus half an hour plus another half an hour. So this is 80 plus 50 is 130. 130 plus 40 is 170. I hope that's right. 12, yeah. Divided by 2 hours. So 170 divided by 2 is 85. So 85 kilometers per hour. Josh, I don't know what to say because this is a public live stream. I don't want to be too offensive, but maybe you need to close down the browser and try it again. But the answer here is 85 kilometers per hour, so choice C, and that's correct. Okay, so for the third one, which pair of graphs, what does it say? Which pair of graphs represents the same motion of an object? So we have to look at each of these graphs. There's a displacement versus time graph and a velocity versus time graph. And we need to figure out which one is showing the same type of motion. So if we look at, we'll just have to look at each of the individual choices. For choice A, it has this curve for displacement over time. That means that distance is increasing at an increasing rate. So that means that this object is accelerating. Okay, so that means this is some type of acceleration for that displacement versus time graph. And then for the velocity versus time graph, you see that the velocity is increasing as the time is increasing. The velocity is changing, it's also increasing. So this, when velocity is changing, that means that it's also accelerating. So we both have positive acceleration here, so just by luck, the answer happens to be choice A. Okay. The other ones don't make any sense. This shows that you have a negative displacement and it's increasing at a constant rate. So that means that the velocity here would be 0. And this, you have a negative velocity. So these have contradicting answers. Actually, all the other ones have contradicting answers, B, C, and D. A is the only one that makes sense. The Warriors, Artesia. For number 4 says a car traveling on a straight road at 15 meters per second accelerates uniformly to a speed of 21 meters per second in 12 seconds. The total distance traveled by the car in this 12-second interval is blank. So I'm trying to find distance. So the way I'm going to solve this, I'm going to use that whole listing out my givens and picking the formula stuff. So my givens are 15 meters per second. This is initially. So this is V initial equals 15 meters per second. Accelerates uniformly to a speed of 21 meters per second. 21 meters per second is my final speed. 21 meters per second. In 12 seconds. Time equals 12 seconds. The total distance by this car, oh, so that's my distance. So that's my unknown. That's what I'm solving for. There's one thing that we need to solve for in this problem in order to get our answer. We actually need to determine the acceleration. We need to figure out the acceleration to get our distance. Because if we look at our reference table, on the last page of our reference table, we can use this formula. use this one. Oh, not that one. That one's stupid. This one. D equals VIT plus 1/2 AT squared. We need to figure out the acceleration. Acceleration is delta V over T. And when we plug in these values here for final, initial, and time, we get 21 minus 15, which is 6 meters per second over 12 seconds, which equals 0.5 meters per second squared. And then now we need to plug this value into this formula. Let me do that in a different color. So we're going to get D equals V initial, which is 15, times time, which is 12, plus 1/2 times the acceleration, which is 1/2, times the time squared. And I'm just going to hope that I get this right. But the answer is 216 when we plug that into a calculator. 216 meters. Okay. So that would be choice C. So for this problem, this is a time-consuming problem because it requires you to. It's a two-step problem. You have to solve for the acceleration first, then the distance. No matter what formula you use from the reference table, you have to use the acceleration. You have to figure out the acceleration. So even if we use this formula, VF squared equals VI squared plus 2AD, we have everything here except for the acceleration. You need to solve for the acceleration. Okay, let's move on to the next one. Number 5 says an object accelerates uniformly from 3 meters per second east to 8 meters per second east in 2 seconds. What is the magnitude of the acceleration of the object? So it's asking for the acceleration. It gives us our initial speed, which is, well, our initial velocity since it's a direction, 3 meters per second east, and our final velocity is 8 meters per second east, and our time is 2 seconds. So we're going to use the formula acceleration equals delta V over T. That is 8 meters per second east minus 3 meters per second east divided by 2 seconds. This is 5 divided by 2, or 2.5 meters per second squared. So that would be choice A. Is that correct? Yeah, that's correct. Okay. Sometimes it may be a good idea to substitute your units and directions into the formula, so that way you could see like this also would have an eastward acceleration, because east minus east is east. Okay. Oh, someone asked, how come we don't use 9.81 for acceleration? So 9.81 meters per second squared, that value is only for objects that are falling near the planet Earth or on the planet. That's the acceleration due to gravity. So you don't have to use that for problems that are just moving in a horizontal line. Question like number 4 and 5, you assume that it's on some flat surface and it's moving. Okay. Okay, the next two questions are a two-part question. It says, base your answers to questions 6 and 7 on the graph below, which represents the motion of a car during a 6-second interval. Number 6 says, what is the total distance traveled by the car during the 6-second interval? Okay, so we're given a velocity versus time graph. Velocity versus time graph. And something that I like to just remember for any graph, actually, velocity versus time, acceleration versus time, distance versus time, whatever, is you can do two things. You can either figure out the slope of the function on that graph, or you can figure out the area under the function of that graph. So one thing that I remember is slope is always the y-axis over the x-axis. So slope is always y over x, which in this case it would be velocity divided by time. Velocity versus time, velocity divided by time, we just figured it out in the last two problems. This is acceleration. So this is not what we need to figure out, the slope. The question is asking for the total distance, and if we're doing velocity versus the velocity divided by time, we get acceleration. So this is not what we want to do. The other thing we can do is the area. The area, instead of dividing, the opposite of division is multiplication. So that's your x variables times your y variables, and that would be velocity times time. And if you look on your reference table on the last page, the very first equation is v bar equals d over t. And if you do some algebra, you get velocity times time equals distance. So this is what we need to figure out. We actually need to figure out the area under this curve, under this function, under the 6-second interval. So this is the whole curve. I'm saying curve, but I mean function. So how do you figure out the area of this shape? Well, just looking at it, you might not be able to, but you can split it up into a rectangle, figure out the area of this rectangle, and add it to the area of this triangle. Okay? So we have to figure out the area of the rectangle and the area of the triangle. We have to add them together. So for the area of the rectangle, that one's easier to figure out. It's length times width. The length of my rectangle goes from 0 to 10, so that's 10 meters per second, times the width, which is 4 seconds to 6 seconds. That's a difference of 2 seconds, so 2 seconds. And this gives me 20 meters per second times seconds equals meters. I'm not done here. Notice choice B is an answer, 20 meters, but that's not what we want to pick. Okay, because we're not finished. We also need to figure out the area of the triangle. The area of a triangle is 1/2 base times height. So the base goes from 0 to 4 seconds, so 4 seconds. And the height goes up to 10 meters per second as well. So that's 10 meters per second. I also need to multiply by 1/2 because that's the area of a triangle, so 1/2. So 1/2 times 10 is 5 meters per second. 5 meters per second times 4 seconds equals 20 meters. Okay, so we have 20 meters for the triangle, 20 meters for the rectangle. So the total distance traveled is 40 meters. Okay, 40 meters. That would be choice C for 6. Okay. For number 7, what is the acceleration of the car at t equals 5 seconds? So now they're asking for a specific point on the graph here. At 5 seconds, this is 5 seconds right here. So they want to figure out the acceleration at this point on the graph when the velocity is 10 meters per second at 5 seconds. Well, now this is where we look at the slope. The acceleration up here is given by our slope. What's the slope at this point on the graph? Well, the slope is 0 because it's a completely horizontal line. So the person that just asked the question, could you just pick the point on the graph that is 4 seconds, 10 meters per second? No, 10 meters per second is our speed, our velocity at that point. However, the car has been traveling for 2 seconds at 10 meters per second. So it's not accelerating. It's actually traveling at a constant speed. And that's given by the slope of this graph here. Okay, so the answer here is A, 0 meters per second squared, because of this horizontal slope. Uh-oh. Looks like some people are having some trouble. Okay, it's back. And I was talking about the previous question. What previous question? Number 6? Oh, number 6, 10, 10 times 4. I mean, that seems to be by chance that if you look at 5 seconds or 4 seconds and you multiply it by 10, you get 40 meters. But that's not the correct physics way to figure out the answer to number 6. Okay, the way you have to figure out the answer to number 6 is figuring out the area underneath this function, and that's the area of a rectangle and the area of a triangle, and you add them together. That's 40 meters. Okay. Okay, so I'm going to move on to the next question. The next questions, 8 and 9, they're together as well. This says a stream is 30 meters wide and its current flows southwards at 1.5 meters per second. A toy boat is launched with a velocity of 2 meters per second eastward from the west bank of the stream. Number 8 says how much time is required for the boat to reach the opposite bank of the stream. So for this one, depending on how much time you'll have, I suggest drawing a picture. Right, here's my river. This is my river. Okay. And it says that it's 30 meters wide. This is my west side. This is my east side. It says that the current of the river is flowing 1.5 meters per second southward. So let's assume south is down. Okay, so I'm just going to draw a little compass here. So this is north. So that means south is down. So this is 1.5 meters per second. That's the speed of the river. And then it says a toy boat is launched. Here's the boat. It's launched at 2 meters per second eastward from the west side to the east side. The question is asking how much time is required for the boat to reach the opposite bank of the stream. So we're given, if we list out these variables, we're given basically a Vx speed of 2 meters per second, and we're given a Vy speed of 1.5 meters per second. We're given a distance in the x direction, which is 30 meters, and we need to solve for the time. Well, if we're using the formula on the reference table, average velocity equals distance over time, and we're solving for the time, we can rearrange this formula to t equals d over v bar. Okay, so the time equals the distance over the average speed. If we are if we're talking about the horizontal speed, okay, then we need to use the horizontal distance that we're given. So we're going to substitute our horizontal values, which is our x values. So that would be 30 meters divided by your speed, your horizontal speed, which is 2 meters per second. And this you'll get 15 seconds as an answer. Okay, so you actually don't have to include this 1.5 meters per second, the speed of the river for number 8. Okay, that's not important because the time it takes to reach the river to reach from one side of the river to the other is determined using our x variables, our horizontal variables. For number 9 is now when we have to do some vector addition. It says, what is the magnitude of the boat's resultant velocity as it crosses the stream? So resultant means that we have to add our velocity vectors. Okay, so we have one vector that's going 2 meters per second east, and we have another vector. Let me whoops. Let me add this other one here. We have another vector 1.5 meters per second south. So obviously this is not drawn to scale. So 2 meters to the east and 1.5 meters per second. Whoops. It says milliseconds, meters per second south. And so now we want to draw a resultant vector, which is going to be connected from our tail of our first vector to the head of our other vector. So this is our resultant vector here. Now it forms a right triangle, so all we have to do is a squared plus b squared equals c squared. So that would be 2 meters per second squared plus 1.5 meters per second squared equals our resultant squared. When we plug that into our calculator, we're going to get an answer of 2.5 meters per second for C. So C equals 2.5 meters per second. Okay, and just like in math class, your resultant, if it's the hypotenuse, obviously it's the hypotenuse of your triangle, your hypotenuse is always the longest side of your triangle. So 2.5 is larger than 2 and 1.5. All right, so the answer is B in this case. And the answer for number 8 was C. Okay. So those were relatively easy. Excuse me, I'm burping into the mic. Let's go on to number 10. A rock is dropped from a bridge. What happens to the magnitude of the acceleration and the speed of the rock as it falls? Neglect friction. So it says it's dropped from a bridge. Dropped from a bridge or anything dropped means that it's going to be undergoing free fall. Okay, because we're ignoring friction, this object is going to be free falling. Okay, so in free fall, everybody's favorite number, acceleration due to gravity equals 9.81 meters per second squared. This is the acceleration due to gravity. So that means that the acceleration is remaining the same. This is constant. So choice A is eliminated because it says that the acceleration is increasing. And choice C is eliminated because it says the acceleration is increasing. As an object is falling, it's going to get faster and faster, right? So here is a motion diagram as the object is falling down. Notice the distance between each dot is getting further apart. That means that the object is accelerating. So the speed is increasing. So therefore the answer is D. The acceleration remains the same as the speed increases. Okay. Number 11 says a 25 Newton weight falls freely from rest from the roof of a building. What is the total distance the weight falls in the first second? Okay, so this is let's see how we can figure out how to do this problem. So I'm going to list out my variables. It says a 25 Newton weight. 25 newtons, this is the weight of the object or the force of gravity of the object. So that's 25 newtons. That's the weight of the object. It says falls freely from rest. That means the initial speed is 0 meters per second. What is the total distance the weight falls in the first second? So t equals 1 second, and we're solving for the distance. Okay. Something else that we have here is acceleration. Acceleration due to gravity is 9.81. We know that we can use this acceleration because it says it falls freely. Okay, so that means acceleration equals 9.81 meters per second squared. Okay, so at this point, I'm going to look at my reference table, and I'm going to look for a formula on the last page, because this is a mechanics question, that involves acceleration, initial speed, time, and distance. And that would be this formula. D equals VIT plus 1/2 AT squared. Okay, so this formula has distance as my unknown, V initial, which would be 0. So that means this whole term is 0. And it simplifies to D equals 1/2 AT squared. And if I substitute my values in here, I'm going to have 1/2 times 9.81 times T squared, which is 1 squared, which is 1. So I get an answer of approximately 4.9 meters. Whoa, you guys hear my cat? Okay. Okay, so the answer is C, 4.9. Okay. So moving on, number 12 says a plane flying horizontally above Earth's surface at 100 meters per second. This is important. Plane flying horizontally. It's flying at 100 meters per second, right? So this is my horizontal speed. V horizontal equals 100 meters per second. The crate strikes the ground 30 seconds later. This is my time, 30 seconds. What is the magnitude of the horizontal component of the crate's velocity just before it strikes the ground? Neglect friction. Okay, so here I am writing out variables. This problem doesn't involve any type of math, actually. Because the plane is flying horizontally, right? If we have a plane like this, let's say this is the plane. There's the plane, okay? It's flying this direction, and it's going to drop a crate. This speed is 100 meters per second. If it's going to drop a crate, the crate is going to fall in this direction, right? It's going to be a parabolic motion, but it's also going to fall at this the speed that the plane was flying at. The speed of the plane was 100 meters per second. The crate is going to fall out of the plane horizontally at 100 meters per second. Okay, so this is also 100 meters per second. And when we learned about projectile motion, the horizontal component, horizontal velocity, always stays the same. So the final equals the initial, just like Ashley says. So when it hits the ground, it's going to hit the ground at 100 meters per second, moving horizontally. So the answer is B. So there's no math here, okay? There's no math involved. All right. There is no, the reason why is there is no acceleration in the x direction, okay? The acceleration in the y direction equals that 9.81 meters per second squared. In the x direction, there is no horizontal, okay? All right. Next, number 13 says, a ball is thrown horizontally at a speed of 20 meters per second from the top of a cliff. How long does the ball take to fall 19.6 meters to the ground? So I usually like to draw a picture. I'm going to forgo the picture. I'm just going to do the math here. It says a ball is thrown horizontally at a speed. So that is Vx, my horizontal speed, which is 20 meters per second from the top of a cliff. How long does the ball take? So that's time, that's what I'm solving for, to fall 19.6 meters. That's my distance in the y direction. My distance in the y direction. This is falling 19.6 meters. 19.6 meters. Something else that we have is the acceleration in the y direction, which is 9.81 meters per second squared. And we also have the speed in the y direction initially, which is 0 meters per second. Okay? The speed in the y direction is 0. That's because the speed initially is only horizontal, which is 20 meters per second. Okay, so if we did draw a picture, it looks like this. Here's my cliff. Here's the ball. It's thrown horizontally. This is 20 meters per second, and it's going to fall down this way. Okay. So we actually don't need to use our x variable. This 20 meters per second is unnecessary. And actually, when you're solving for the time, you always want to use your y variables. So again, we're going to use this formula, d equals VIT plus 1/2 AT squared. Distance is 19.6 meters. My initial speed in the y direction is 0, so this whole term cancels out. And I'm going to have 1/2 A, which is 9.81, and t squared is what I'm solving for. Okay, so I'm gonna do some math here, and I'm gonna have to take the square root in my calculator, and the answer that I get is approximately 2 seconds, I believe. Okay, 2 seconds. So that would be B. So notice your answer here is t squared. If you just left it at t squared equals 4 seconds. And look, there's an answer there for 4 seconds. But you need to remember that you're solving for t. This would be 4 seconds squared. You're solving for t, not t squared. So you have to make sure that you take the square root for this case. Okay. For number 14, a basketball player jumped straight up to grab a rebound. If she was in the air for 0.80 seconds, how high did she jump? Okay. Let's look at this problem. This problem only gives us one variable. Excuse me. T equals 0.80 seconds. The question is asking for how high did she jump, so dy, or the height. What else do we have? Well, we also have a acceleration in the y direction is 9.81 meters per second squared. And we know also that if she is, let me draw a picture here. Here's the ball in the air. Here's the girl, basketball player. She's jumping up like that. Okay. There you go. Okay, excuse my drawing, but there's my drawing. So now what formula do we need to use here? Well, let's look on a reference table. So it has time, distance, and acceleration. Time, distance, and acceleration. Well, that one would be this one. D equals VIT plus 1/2 AT squared. I hope. I'm actually, look, now she has a face. Okay, so okay, so when we plug in those values, we get a an answer of what do we get? Okay, so we get a distance of 0.78 meters when we plug this in. Okay, so this is this distance from the ground to the ball. Okay, that's how high she had to jump. Okay, sorry, getting distracted. Okay, number 15. A golf ball is hit at an angle of 45 degrees above the horizontal. What is the acceleration of the golf ball at the highest point in this trajectory? What is it? What is the acceleration of the golf ball at the highest point in this? Okay, so this one's easy. Again, no math involved. So if we have a golf ball, right? This is at 45 degrees. It's hit at 45 degrees. This is the golf ball. The question is asking for what is the acceleration of the golf ball at the highest point in this trajectory. Here's the highest point. Okay, the acceleration at every point in this path is 9.81 meters per second squared downward. Okay, it's always 9.81 downward. This is the acceleration. The reason why is because if you have two accelerations, one in the x direction, which is 0, and one in the y direction, which is 9.81, right? To figure out the resultant velocity, this would be a squared plus b squared equals c squared, or ax squared plus ay squared equals a squared, your total acceleration. That would be 0 squared plus 9.81 squared equals a squared. And you get an answer of a equals 9.81 meters per second squared. Okay? Yes, Shiv, trajectory just means the path. So the highest point in its path, which is here. Okay? So at every point here, it's 9.81. Every single point, it's 9.81. Down, 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 down. Every single point. Okay? Okay, number 16. Number 16 says, a machine launches a tennis ball at an angle of 25 degrees above the horizontal at a speed of 14 meters per second. The ball returns to level ground. Which combination of changes must produce an increase in time of flight of a second launch? Okay, so this is a complex one. So it says it launches a tennis ball at an angle of 25 degrees at a speed of 14 meters per second. The ball returns to level ground, so it's going to go up and then come back down. Which combination of changes must produce an increase in the time of flight? So to increase the time of flight, we actually need to increase the angle. That's one way to increase the time of flight. Okay, so the ones that say decrease the launch angle, that's wrong. So A and B are eliminated, right? Because decreasing the launch angle means that you're getting closer and closer to just rolling it on the floor. So if you decreased it to a smaller angle, it's not going to be in the air for much longer. If you increase the angle, it is in the air for much longer. Okay, so that's either C or D. Now we need to figure out if increasing the ball's speed or decreasing the ball's initial speed is going to increase the time of flight. Well, if we look at speed, actually, you know what? I'll just tell you the answer. The answer is just D, increasing the like that person guessed, increasing the launch angle and increasing the ball's initial speed. Okay, so also the idea is if something's traveling faster, it's going to stay in the air longer, obviously increasing the time of flight. Okay, so that's the answer. Moving on. Number 17, a projectile is fired from a gun near the surface of Earth. This is important, near the surface of Earth. The initial velocity of the projectile has a vertical component of 98 meters per second. Friscoco, okay, well, I'm sorry, has a vertical component of 98 meters per second and a horizontal component of 49 meters per second. How long will it take the projectile to reach the highest point in its path? Okay, so if we draw a picture here, right, it's going to look like this. So it's going to be launched up and then it's going to follow this parabolic motion. So it wants to figure out the time it'll take to reach this point, the apex. Okay, so we have initial in the y direction equals 98 meters per second. A horizontal component, so v initial in the x direction, equals 49 meters per second. We don't have a acceleration in the x direction, so I'm just going to plug ax equals 0. Ay equals 9.81 meters per second squared. And if we're stopping at this point, this is where we want to stop, we need to figure out what the final velocity is. So the final velocity in the x direction is the same as the initial velocity in the x direction. It's not important. I'm just going to write it down just so that we have initial and final. But for the final speed in the y direction, because it's going to be at the top, at the apex of this trajectory, that final speed in the y direction is going to be 0 meters per second. The the gun in this case, is going to fire this projectile, and it's going to stop for a brief moment of time at the apex before it starts to fall back down. Okay, so we're solving for time. Time is our unknown. Okay, so we're going to use these variables right here, v initial, v final, and a, to figure out our time. The formula we're going to use on the reference table is vf equals vi plus at, and we're going to plug that in. So that's 0 equals our initial speed is 98, our acceleration is 9.81, and our time is what we're solving for. We're going to do the math here, and we're going to get t is approximately 10 seconds. Okay, so that answer would be B. Is that correct? Yep, that's correct. Okay. Number 18 says, a projectile is launched at an angle above the ground. The horizontal component of the projectile's velocity, Vx, is initially 40 meters per second. The vertical component of the projectile's velocity, Vy, is initially 30 meters per second. What are the components of the projectile's velocity after 2 seconds? Okay, we can eliminate two parts automatically. Horizontal velocity is always constant during projectile motion. So these ones right here, C and D, can be eliminated because they've changed our horizontal velocity, 20 meters per second. They've decreased it. So can't be C or D. So we're left with A and B. After 2 seconds, right, the vertical component is going to change. It's initially 30, so it's either going to increase or decrease. Choice B has the vertical component staying the same after 2 seconds, right? This is a projectile motion, so the speed is going to change along this path here, so it cannot be B either. So by choice of elimination, no math involved, choice A is the correct answer. Whoops. Okay, next, number 19. Number 19, which situation represents a person in equilibrium? A child gaining speed while sliding down a slide, a woman accelerating upward in an elevator, a man standing still on a bathroom scale, or a teenager driving around a corner in his car. Okay, equilibrium means that the forces are balanced. And if the forces are balanced, if the forces are balanced, that means that acceleration equals 0. If acceleration equals 0, that means that the speed is constant. So therefore, we can eliminate A, a child gaining speed, because speed needs to be constant. We can also eliminate B, a woman accelerating upward in an elevator. Acceleration needs to be 0. We're left with C and D. Teenager driving around a corner in his car. When you're driving around a corner, this is actually centripetal acceleration, centripetal motion. So you actually do have acceleration here pointing towards the center of this circle. So this is not the choice either. So choice of elimination, the answer is C. The person's at rest, which happens to be constant speed. Okay, so V equals 0, which means V is constant. Okay, when V is constant, the object is in equilibrium. For number 20, which object has the greatest inertia? Inertia, when you see this word, automatically you want to associate it with mass. So which object has the greatest mass? That would be choice D, 1,500 kilogram car. These choices include speed. Speed is not important when talking about inertia. So the answer is D. 21. Which graph best represents the motion of a moving object with no unbalanced force acting on it? So this word here, no unbalanced force acting on it, it's a double negative. So which object is moving with a balanced force? This means balanced force. And we just finished saying in a few problems ago, a balanced force means it's in equilibrium. So which object shows equilibrium? This one. The velocity is staying the same, means that the velocity is constant. Okay, so this means velocity is constant. This is this one. Velocity is constant. When velocity is constant, that means that acceleration equals 0. And again, when acceleration is 0, it means that you're in equilibrium. Okay? Choice D, like some of you guys said, choice D says that as time is increasing, velocity is increasing. Okay? So this one's a tricky problem because of the way that they word it. No unbalanced force. No unbalanced force means that there's a balanced force. The forces are balanced, okay? Meaning the object is in equilibrium. Moving on, number 22, it says a 4-kilogram object. 4-kilogram object is accelerated at 3 meters per second squared north by an unbalanced force. The same unbalanced force acting on a 2-kilogram object will accelerate this object towards the north at what acceleration? Okay. So how do we do this one? So let's try doing this by listing out our variables. We have a 4-kilogram object. This is our mass. And the acceleration is 3 meters per second squared north by an unbalanced force. The same unbalanced force, so F equals something, okay? The same unbalanced force acting on the 2-kilogram object, so now we have another mass, which is 2 kilograms, will accelerate this object towards the north at what? So we're actually solving for this second acceleration here. So what's going to kind of unify or bring these two objects together actually is Newton's second law, which is F net equals mass times acceleration. So they're the same force actually. So this right here, mass times acceleration, should equal this mass times acceleration here. So it's going to be 4, what's this kilograms? Whoops. 4 kilograms times 3 meters per second squared equals 2 kilograms. Why do I keep putting kilometers? 2 kilograms times the acceleration. Okay, so we get 12 newtons on the left side equals 2 kilograms times the acceleration, and you get acceleration equals 6 meters per second squared. 6, not 16, 6 meters per second squared. So that would be B. Okay. So next, a baseball bat exerts a force of magnitude F on a ball. If the mass of the bat is 3 times the mass of the ball, the magnitude of the force of the ball on the bat is blank. So it says a baseball bat exerts a force of magnitude F on a ball. If the mass of the bat is 3 times the mass of the ball, the magnitude of the force on the ball on the bat is blank. So just by looking at this, people may think that the answer may be C or D, but this is a Newton's third law question, which means the force of the bat on the ball equals the force of the ball on the bat. Whoops, bat. Okay, so the answer would be A, F. Okay. 24 says, on the surface of Earth, a spacecraft has a mass of 2 times 10 to the 4 kilograms. What is the mass of the spacecraft at a distance of 1 Earth radius above Earth's surface? Okay, so this is another like trick question. It's asking for the mass. It gives you the mass. So it says the spacecraft has a mass of 20,000 kilograms. What's the mass of the spacecraft? So that would be B. Okay. Mass doesn't change. Mass doesn't change. Mass is how much stuff you have, how many, like basically how much atoms you have. And so if you're going from on the planet to away from the planet, you're not going to lose any mass. Okay? So the answer is B. That's a trick question. 25. A person weighing 785 newtons on the surface of Earth would weigh 298 newtons on the surface of Mars. What is the magnitude of the gravitational field strength on the surface of Mars? So it says person, so the force on Earth equals 785 newtons, but the force on Mars equals 298 newtons. We know the acceleration due to the Earth's gravity. Acceleration on Earth equals 9.81 meters per second squared, and we're trying to solve for the acceleration on Mars. Acceleration due to gravity on Mars. Okay, there's 2 ways to do this. You can do a series of like solving for the mass, and then solving for the mass of the object on Earth, and then plugging it into to Newton's second law. I'm just going to set up a ratio. So it's going to be Earth 785 over 9.81 equals 298 over x. Where's my calculator? Okay, so solving for x here, we get 785 divided by 9.81, and then 298 divided by 80 equals 3.72. So the answer here is B. So x equals 3.72 newtons per kilogram. The reason why it's newtons per kilogram is because Shiv, you put a formula in the chat. Fg equals mg. We're solving here for g, so that would be Fg over m. And the units for Fg over m is newtons per kilogram. That's why we have the unit for newtons per kilogram. Okay. Next, number 26 says, an 8-Newton wooden block slides across a horizontal wooden floor at constant velocity. What is the magnitude of the force of kinetic friction between the block and the floor? So here I think is the only friction problem. Force of kinetic friction. So what's the force of friction? Well, the force of friction is given by mu, which is the coefficient of friction, times the normal force. Because the object is on a horizontal surface, the normal force equals the force of gravity. And we have our force of gravity right here, which is 8 newtons. So the friction force is going to be mu times 8 newtons. Well, what's this coefficient of static friction? Well, we have wood block on a wooden floor. On the reference table, it's on page 1, very first page. Wood on wood for kinetic is 0.30. Okay, so mu for wood on wood equals 0.30. So we're going to plug that in. 0.3 times 8 newtons equals this 2.4, I think. I hope. Yeah, A. Okay, newtons. Okay, there is no unit for the coefficient of friction, so we don't need to plug in any units for that. For number 27, it says a car's performance is tested on various horizontal road surfaces. The brakes are applied, causing the rubber tires of the car to slide along the road without rolling. The tires encounter the greatest force of friction to stop the car on what? Okay, well, from the previous equation, we have the force of friction is proportional to the coefficient of static friction. We want the greatest force of friction. So we want to find the greatest value for mu. And that would be between dry concrete, dry asphalt, wet concrete, and wet asphalt. The highest number there is dry concrete. Dry concrete. Okay, this has a value of 0.68. Dry asphalt has a value of 0.67. Wet concrete has a value of 0.58, and wet asphalt has a value of 0.53. Okay, so we need to use our kinetic coefficient values because the object is in motion, and it's required to stop the car. That's kinetic friction. The choice is A. Okay, for number 28, the diagram below represents two satellites of equal mass A and B in circular orbits around a planet. Compared to the magnitude of the gravitational force of attraction between satellite A and the planet, the magnitude of the gravitational force of attraction between satellite B and the planet is blank. Okay. We need to use this formula. Fg equals big G times m1 m2 over r squared. Okay, and the only thing that is changing actually, since the mass of choice A, the mass of planet A and the mass of planet B are the same, nothing on the numerator is changing. Everything here is constant. The only thing that's changing is the distance. Between the planet and A, it's r. Between the planet and satellite B, it's 2r. So we're going from r to 2r. And because the denominator is squared, this is actually, so r squared becomes 4r squared. Okay? So this is on the denominator. So if we rewrite the equation, we get Fg equals a whole bunch of constants divided by 4r squared. So if this is being divided by 4, then this is being divided by 4. So that means that the answer is C, 1/4 as great, which is 1/4. 1 over 4. Okay. So just to repeat, if you're dividing by 4 on the right side of the equal sign, you have to divide by 4 on the left side of the equal sign to make sure that you're balancing the equation. Okay, Shiv, I do have my my water here. So number 29 says, two 20-Newton forces act concurrently on an object. What angle between these forces will produce a resultant force with the greatest magnitude? Concurrently means at the same time. At the same time. So if you're not good at vectors or geometry, then you're going to, what you're going to have to do is like test each one of these. 0 degrees means that the object has the forces in the same direction. This is 0 degrees. And you get a resultant force of this much. 45 degrees looks like this. So here's one. And 45 degrees would be here. Okay. You get a resultant of there. 90 degrees is this one and this one. You get a resultant of that. And 180 degrees looks like here's that one and in the opposite direction. So you actually get a resultant of 0. So the one with the longest arrow is obviously this one. So it's part A. Okay. Number 30. The diagram below represents two concurrent forces. Which vector represents the force that would produce equilibrium with these two forces. The force that would produce equilibrium. So if we figure out what our resultant force is here, we have one arrow going up and then one arrow going to the left. We're adding it by head to tail. We get a resultant force that points up and to the left. Okay. Also using the parallelogram method, if you construct a parallelogram and bisect this, it's the same arrow. Okay. It's asking what force will produce equilibrium. So what arrow will cancel this arrow out? Well, that would be C. Okay. In order to produce equilibrium, we need balanced forces. So we need a force that points down in this direction. Okay. So let me just label this. This is your resultant, and this is called your equilibrant. Okay. 31. A student on an amusement park ride moves in a circular path with a radius of 3.5 meters once every 8.9 seconds. The student moves at an average speed of blank. Okay, so we have radius equals 3.5 meters. We have a time of 8.9 seconds. The student moves at an average speed. We're trying to figure out the speed. So speed for a circle is distance over time. The distance, in this case, around a circle, the distance around a circle is the circle. I'm going to keep it as a time. So we substitute our values. You get 2 pi times 3.5 over 8.9. And if you substitute this, we get 2 times 3.14 times 3.5 divided by 8.9. And I get a value of approximately 2.47 meters per second, which would be approximately C. Okay. Next question. A car rounds a horizontal curve of constant radius at a constant speed. Which diagram best represents the direction of both the car's velocity and the acceleration? Acceleration always points towards the center, so that eliminates choice A, and that eliminates choice D. This speed, this velocity, the velocity is always tangent to the circle, so this also eliminates choice B. So by choice of elimination, it's C. Okay. Next. 33 says an unbalanced force of 40 newtons keeps a 5 kilogram object traveling in a circle of radius 2 meters. What is the speed of the object? So you have force equals 40 newtons. You have mass equals 5 kilograms. You have radius equals 2 meters. What is the speed of the object? So you know that force equals mass times acceleration. And also for centripetal acceleration, you know it's v squared over r. So now we just need to substitute this acceleration into this acceleration. So we get F equals mass times v squared over r. And if we substitute these values, you get 40 equals 5 times v squared is what we're solving for, divided by 2. And so that's let's figure out what this is. So we get v squared equals 16, and v would equal to 8 meters per second. That's our answer, A. Okay. Next, the magnitude of the momentum of an object is 64 kilogram meter per second if the velocity of the object is double, the magnitude of the momentum will be, okay. Momentum equals mass times velocity. So if our momentum is 64 64 kilogram meters per second, and if we're doubling the momentum, sorry, if we're doubling the speed, if we double the velocity, then the momentum also gets doubled. Okay, mass stays the same, obviously. So if we are doing 2 times the velocity, then you need to do 2 times the momentum. So 64 times 2 is 128. That would be the answer. Oh, whoops. Yeah, going back. Good catch, Nick. The the square root of 16 is 4. Good catch. Okay, so sorry. For 34, 2 times 64 is 128. Okay. For number 35, a 75 kilogram hockey player is skating across the ice at a speed of 6 meters per second. What is the magnitude of the average force required to stop the player in 0.65 seconds? So we have mass equals 75 kilograms. We have a speed, which equals 6 meters per second. We have time, which equals 0.65 seconds. And we need to figure out the average force. Okay, so this is impulse. Impulse equals the force times time, and that also equals the change in momentum. Okay, so we don't have a value for J, so we're just going to be using this part of the formula here. So we have force times time equals delta P. Delta P is P final minus P initial. So mass P final minus P initial. And P equals mass times velocity minus mass times initial velocity. So the initial velocity is 6 meters per second. The final velocity is 0 because we want to stop the object. So it's force times time equals mass times the initial speed. So this is the formula that we're going to be solving. Okay. So if we substitute our values, we're going to get F equals 75 times 6 divided by 0.65. And let's see what we get. We get 75 times 6 divided by 0.65. We get 692 newtons. The answer that's closest to that is 690. So the answer is C. Number 36, a 0.45 kilogram football traveling at a speed of 22 meters per second is caught by an 84 kilogram stationary receiver. If the football comes to rest in the receiver's arms, the magnitude of the impulse imparted to the receiver by the ball is, okay, a lot of stupid words there, but J equals F times T, which equals delta P. In this case, we're going to use J equals delta P. So that's impulse equals P final minus P initial. Okay, so the final momentum, the football comes to rest, the final momentum is 0. So that's J equals the initial momentum. So the impulse equals the initial momentum. Now what we're going to do is we need to figure out what the initial momentum is. So the initial momentum is, you have this football traveling at this speed. So that would be 0.45 kilograms times 22 meters per second. And you get a value of 0.45 times 22. You get 9.9 Newton seconds. Okay. The unit for impulse is Newton seconds because force times time is Newton times seconds. So this is our answer, choice B. Okay, for 37, when a 1 kilogram cart moving with a speed of 0.50 meter per second on a horizontal surface collides with a second 1 kilogram cart initially at rest, the cart locks together. What is the speed of the combined carts? So this is a collision problem, and it says the carts lock together. So that means that it's an inelastic collision. Okay? So that means that the objects will have an added mass together and that they move with the same speed, final. So what's the speed of the combined carts after the collision? That's actually what we're solving for, V final. Okay, so we have M1 equals 1 kilogram. We have M2 equals 1 kilogram. You have V1 initially equals 0.50 meters per second, and V2 initially equals 0 meters per second. It's at rest. Okay, so the formula that we have to use here is the momentum initially equals the momentum after. So that's our total momentum before equals our total momentum after. So the total momentum before is m1 v1 plus m2 v2, and the momentum afterwards is, because it's an inelastic collision, you have m1 plus m2 added together, they stick together, times the final speed. Okay, so m1 times v1, which is 0.5, plus m2 times v2, 1 times 0 is 0, equals m1 plus m2, which is 2 times v final. So we have 0.5 equals 2 vf, and we have a final speed of 0.25 meters per second when you divide that in your calculator. So the answer is C. Okay. Okay, 38 says at the circus, a 1,000 kilogram clown is fired at 50 meters per second from a 500 kilogram cannon. What is the recoil speed of the cannon? This is an explosion. Ashley, you asked, well, we have to memorize that. You're talking about memorizing this formula. No, you don't have to memorize the formula. What you do need to know is on your reference table is that your P initial equals P final. And this means your total momentum and your total, so your total momentum before equals your total momentum afterwards. Okay, so there's nothing really you have to memorize for the physics Regents except for a few concepts like conservation of momentum. So for this one, this is, for number 38, this is another conservation of momentum problem. This one is an explosion. So it's the opposite of an inelastic collision. So if we're talking about the momentum before equals the momentum after, you have the initial, so both masses are together. So m1 plus m2 are together, and they have some initial speed, and then they split off, right? So if you drew a picture here, this is the cannon, and here's the clown in the cannon. And then what's going to happen is afterwards, so this is before, this is m1 plus m2, and then afterwards what's going to happen is you're going to have the clown separate from the cannon. Okay, so this is V initial, and this one would be m1 v2 plus m2 v2. Okay, so you have separate velocities. The cannon is going to move backwards while the clown is going to move forward. So you're going to have m1 v1 plus m2 v2. So let's figure out what their masses are. m1 plus m2, that's 100 kilograms plus 500 kilograms. So that's 600 kilograms. And the initial speed of the cannon is going to be 0. The cannon is not moving. Both of the clown and the cannon are not moving. They're at rest initially. Okay? So afterwards, they split off. So the mass of the clown is 100, and the speed of the clown is 15 meters per second, plus the mass of the cannon, which is 500, times the speed of the cannon that it's going to move backwards by. So the left side equals 0 equals 1500 kilogram meters per second plus 500 kilogram times V2. When we solve for V2 here, we get V2 equals 3 meters per second, because 15,000 divided by 500 is 3. Okay, this is 1500. Whoops, 1500. My bad. So we get an answer of C, 3 meters per second. That's the speed of the cannon after it fires. It'll move backwards at 3 meters per second. For number 39, a very easy one. Which term identifies a scalar quantity? Displacement, velocity, and momentum, they all have direction. So these are vectors. So the answer is D, time. Time doesn't have a direction, at least not in Regents physics. For number 40, which two quantities can be expressed using the same units? This you'll have to go through it. Unless you know these quantities by heart, you'll have to go through it. So energy is, the unit for energy is joules. The unit for force is newtons, so it's not A. The unit for impulse is the Newton second. The unit for force is the Newton. It's not B. C says momentum and energy. The unit for momentum is the kilogram meter per second. And energy is joules. These are not the same. Impulse and momentum. Impulse and momentum has Newton seconds and kilogram meter per second. We need to figure out if these are equal. Obviously, this is the correct answer, but let's just check to see if they're equal. A Newton is a kilogram meter per second squared times, we're bringing down this second here. When we simplify this, we get kilograms times meters per second squared. Second times 1/2 squared is second. So this equals the kilogram meter per second. Okay, so they are equal indeed, impulse and momentum. Okay, you can also just verify using this formula. Impulse equals delta P. Impulse equals delta P. Okay, next. Okay, so for 41 to 43, this involves doing a graph. It says plot the points for force versus elongation, draw the best fit line, and using the best fit line, determine the spring constant of the force. Show all work. So I'll need to figure out a scale for this, right? So I have force, applied force is my y coordinates here. These are my y coordinates, and the elongation of a spring are my x coordinates. So let's see, 2, 4, 1, 2, 3, 4, 5, 6. Let me just quickly do this graph. Okay. All right. So I'm gonna do 0.2, 0.4, 0.6, 0.8. And this is gonna be 1.0. Okay, so quickly plotting this, we have 0, 0 as 1 point. I'll change this color, 0, 0. We have 0.16 and 4. So that's like here. 2.7, 0.27 and 8. which is here. We have 0.42 and 12, 11, 12, which is like here. You have 0.54 and 16, which is here. You have 0.71 and 20, which is about here. Okay, so there's my points. The best fit line, you want to use a straight a straight edge or a ruler. So here's my best fit line. Whoops. That's not my best fit line. This is my best fit line. Okay, so there's my best fit line. It's gonna connect as many points as possible. When I say connect, I don't mean connect the dots. It's just gonna touch as many points as possible. All right, so 44, using the best fit line, determine the spring constant of the spring. So spring constant. Spring constant shows up in two places. For this problem, it's force versus elongation. So force versus x. Okay, so force in the spring versus x. The formula in the reference table you get is the force in a spring equals kx. It's asking to solve, number 44 is asking to solve for the spring constant. K is my spring constant. So solving for K gives me force on a spring divided by x. Or the force, this is my Fs, versus my elongation, which is x. Okay? So I'm going to figure out the slope here. So I'm going to pick a point. I'm going to pick 2 points and then figure out the slope. So I'm going to pick these 2 points here, this one and this one. Okay, you can pick any 2 points. So this one is this one and this one is this one. So Fs would be 12 minus 4 divided by 0.42 minus 0.16. And I'm going to get 8 over 0.42 minus 0.16. 8 over 0.26. And 8 divided by 0.26 equals approximately 30.7. The units are newtons per meter, right? Newtons divided by meter. So that's my approximate spring constant value. Okay, so you're figuring out the slope. Next. Base your answers to questions 45 to 48. A spark timer is used to record the position of a lab cart accelerating uniformly from rest. Each 0.10 second, the timer marks a dot on the recording tape to indicate the position of the cart at that instant as shown. Number 45 says, using a metric ruler, measure the distance the cart traveled during the interval. T equals 0 second to T equals 0.30 second. Record your answer. Okay, well, this is going to be difficult since I don't have a ruler. But if this is 0, this one represents T equals 0.10. This one represents T equals 0.20. This one represents T equals 0.30. This equals 0.40. And this one represents T equals 0.50 seconds. Okay. So the question is asking, measure the distance the cart traveled during the T equals 0 to T equals 30. So we would have to figure out the distance from here to here using the ruler, using the centimeter side. Okay? And then we round our answer. And then for 46, let's say we get something like, let me estimate what this looks like. 1, 2, 3, 4, 5. Let's say we get 5 centimeters. So we get approximately 5 centimeters. It says calculate the average speed of the cart during that same time. So the average speed is distance over time. If our distance is 5 centimeters and our time is 0.30 seconds, we get an average speed of 5 divided by 0.30, which is approximately 16.7 centimeters per second. If you want to turn this into meters per second, all we have to do is divide by 100, which would be 0.167 meters per second. Okay? 47, it says calculate the magnitude of the acceleration of the cart during this time interval. Acceleration equals v final minus v initial over time. Okay, if our final speed was 0.167 meters per second and our initial speed was 0, our time is 0.30 seconds. We're just going to divide our answer from our previous problem by 0.30 again. And we get an acceleration of approximately 0.5 Hello? Okay. Sorry, I got kicked out. My internet. All right, so where was I? Resuming. Acceleration is going to be approximately 0.56 meters per second squared. So something I just want to clear up is that I just estimated my values. You'd actually have to measure it yourself to figure this out. So number 48 says, on the diagram below, mark at least 4 dots to indicate the position of a cart traveling at a constant velocity. Constant velocity means that each dot is going to have an equal distance. So again, using your ruler, you're going to be measuring these distances to make sure that they are equal distance. Okay, so this is the same distance as this, and the same distance as this. Okay, 4 dots. It says at least 4 dots. Just draw 4 dots. Don't try to do more, because if you mess up on the 5th dot and you accidentally put it here, this distance here is greater than D, so you would mark it wrong. You get it marked wrong. Okay, so just stick to the instructions. Okay, so that ends like the easy stuff. The other stuff now, the hard physics, which is electricity and magnetism. Hopefully I can do that in an hour, because I don't want to be here past 8:30. Okay. Okay, so this is the second review packet, and this deals with electricity, magnetism, waves, circuits, and modern physics. So for this one, it's starting out by saying a shopping cart, oh, and energy also it has. A shopping cart slows as it moves along a level floor. Which statement describes the energies of the cart? So it slows as it moves along a level floor. Okay? If it's on the level floor, that means potential energy stays the same. So choices B and D are eliminated because it says potential energy is increasing or decreasing. It's on a level floor, so it's going to stay the same. Kinetic energy is proportional to the velocity. So if the cart is slowing down, that means that the kinetic energy will also decrease. Okay, so if the speed decreases, the kinetic energy decreases. Okay, so that's part C. For number 2, it says while riding a chairlift, a 55-kilogram skier is raised a vertical distance of 370 meters. What is the total change in the skier's gravitational potential energy? Gravitational potential energy equals mass times the acceleration due to gravity times the height. We plug in our values here. Mass is 55 kilograms times the acceleration due to gravity, 9.81 meters per second squared, times the height, which is 370 meters. We get 55 times 9.81 times 370. Geez, it's a big number. We get 199,633.5 units are joules. Okay. We notice everything is in scientific notation. So this is 1, 2, 3, 4, 5. 1.9 times 10 to the 5 joules. This is closest to D, which is 2.0 times 10 to the 5 joules. Okay, the answer is D. For number 3, it says a 1.5 kilogram cart initially moves at 2 meters per second. It is brought to rest by a constant net force in 0.30 seconds. What is the magnitude of the net force? Okay, here we have mass, which is 1.5 kilograms, initially moving at 2 meters per second. It is brought to rest, so V final equals 0 by a constant net force in this many seconds. What is the magnitude of the net force? Okay, so this happens to be a impulse question, actually. So impulse equals F net times T equals delta P. We're using this part of the formula. Okay, so F net times time equals P final minus P initial. F net is what we're solving for. Time is 0.30 seconds. P final is 0, and P initial is 1.5 times 2. So we have F net equals 3 over 0.3, which equals 10. 10 newtons. For number 4, which quantity is a measure of the rate at which work is done? Okay. The rate at which work is done. Anytime you see rate, it means it's always something over time. So work over time actually equals power. This is a formula in your reference table. Power equals work over time. Okay, so the answer is B, the rate at which work is done. So rates mean something over time. Okay, so the rate at which velocity changes is acceleration, because it's velocity over time. Okay, for number five says a 70 kilogram cyclist develops 210 watts of power while pedaling at a constant velocity of 7 meters per second east. What average force is exerted eastward on the bicycle to maintain the constant speed? Okay, this seems like a complicated question, so what I'm going to do, anytime I feel like it's a complex question, I'm going to list out my variables. So I have mass equals 70 kilograms. Uh, 210 watts of power, that's obviously power equals 210 watts. Constant velocity, V equals 7 meters per second east. What average force is exerted eastward? So F equals question mark. I'm going to look at my reference table. This is electricity and power. So I'm going to, oh, this is not electricity, sorry, this is power. So I'm going to go on the last page of the reference table and look for my formula for power. I see a set of formulas that look, whoops, that look like this. P equals work over time. Can't use that one. So the next one is force times distance over time. I don't have distance and I don't have time, so I can't use that one either. The last one is force times average speed. I can use this. So I'm going to use this formula with power. So power equals force times speed. Power is 210. Force is what I'm solving for. Velocity is 7 meters per second east. 210 divided by 7. This is 21 divided by 7. So it's 30 F, 30 newtons. So the answer is B. Okay, next. Next says a horizontal force of 5 newtons acts on a 3 kilogram mass over a distance of 6 meters along a horizontal frictionless surface. What is the change in kinetic energy of the mass during its movement over the 6-meter distance? Again, this is a lot of words. Let's list out my variables. So horizontal force, so that's force equals 5 newtons, acts on a mass 3 kilograms over a distance, d equals 6 meters per second. It's frictionless surface. What is the change in kinetic energy? So K E equals what? Now it says change in kinetic energy. That's important because there's a formula on the reference table that says this. Work equals force times distance equals change in energy. Okay? So we actually want to use this formula. This formula is actually going to be FD equals change in energy. The only form of energy here is kinetic. Since it's a frictionless surface, it's kinetic energy only. So this is change in kinetic energy. So this mass right here is unnecessary, not needed. So we're going to do 5 times 6 equals our change in kinetic energy. And this equals 30 joules, which is choice C. Okay. Oh yeah, Isabella, thank you. 6 meters. Thank you, thank you. That's a stamp. Just kidding. Okay, number 7. The diagram below shows a moving 5 kilogram cart at the foot of a hill 10 meters high. For the cart to reach the top of the hill, what is the minimum kinetic energy of the cart in the position shown? Neglect energy lost due to friction. Okay, so this part here that says neglect energy loss due to friction, this means that Q, internal energy, equals 0. That's all that means. We don't need it anyway. Okay, so again, I'm going to write out my variables because let's say I have no idea how to do this. So I have mass equals 5 kilograms. The height is 10 meters. For the cart to reach the top of the hill, what is the minimum kinetic energy? So kinetic energy equals what? This is a conservation of energy problem. Okay, there's going to be kinetic energy here. So we need to figure, so at this point here, we have minimum kinetic energy. We also have potential energy, which equals 0 because it's on the ground. And then as it goes up here, the kinetic energy is going to convert into potential energy. Okay, so we're going to assume that kinetic energy equals 0, and we're going to have potential energy at its maximum here. So we need to use this formula that we derive, okay? Kinetic energy equals potential energy. So kinetic energy is going to equal the potential energy, which is mass times acceleration due to gravity times the height. That's 5 times 9.81 meters per second squared times 10. So that's 5 times 10 times 10. That's approximately 500. But this is 491 joules. Okay. So that's the minimum amount of kinetic energy needed to get this cart to the top of the hill. All right. Okay. Next, number 8 says the diagram below shows 3 points A, B, and C in the swing of a pendulum released from rest at point A. Which statement is true about this swinging pendulum? Okay, so for this type of question, you're going to have to go through each choice and see if it's true or not. The potential energy at A equals the potential energy at C. Is that true? Well, here is your quote-unquote ground, and if this height equals this height, then that's true. So that might be true. Let's just see something else. The speed of the pendulum at A equals the speed of the pendulum at B. Is that true? No, it's not. Because for this formula, for this problem, you're going to have kinetic energy equals the potential energy. And back and forth, they equal each other. So if the speed, so this is basically 1/2 mv squared equals mgh. B is not correct because the speed here at A is not going to be equal to the speed at B because you're at different heights. So this is wrong. C says the potential energy at B equals the potential energy at C. The potential energy at B equals the potential energy at C. Again, these are not the same height, so that's not right. D says the potential energy at A equals the kinetic energy at B. This, again, cannot be correct because they're not at the same height. So the answer, choice of elimination, or also just because looking at this, the diagram, the potential energy at A equals the kinetic energy at C, and that's because of this formula here, okay? All the potential energy here gets converted to all the kinetic energy here. Next, number 9, it says a 2-kilogram block sliding down a ramp from a height of 3 meters above the ground reaches the ground with a kinetic energy of 50 joules. The total work done by friction on the block as it slides down the ramp is approximately what? Okay, so we have mass equals 2 kilograms. We have a height equals 3 meters. And we have a kinetic energy when it reaches the ground, 50 joules. The total work done by friction. So we want to figure out Q. Okay. So we're going to have kinetic energy plus potential energy plus Q equals our total energy. All right. So kinetic energy initially is 0. So these are all initial. So we're going to have basically E initial equals E final, conservation of energy. Okay. So the initial kinetic energy is 0. The initial potential energy is mgh, which is 2 times 3 height times the mass times 10. So that's approximately 60 joules. Plus Q initial, which is 0, equals our kinetic energy final, which is 50 joules, plus the potential energy when it's on the ground, it's 0, plus Q, right? Q final is what we're solving for. So when we do our math here, we're going to get Q equals 60 minus 50, which equals 10 joules. So I estimated 9.81 is 10, so that's why the answer is B, 9 joules. Okay. Another way to do this is if you use this formula, E equals KE plus PE plus Q, is if you set this, why will the initial kinetic energy be 0? The initial kinetic energy is 0 because it's not moving. So it's on a ramp, right? It's on a ramp. Here's the block. And initially you assume it to not be moving. So if the initial speed is 0, then the initial kinetic energy is 0. And then when it gets down to the bottom of the ramp, that's when it says here at the bottom of the ramp, that's the final kinetic energy. Okay, so let's move on to the next one. Number 10. Number 10, a small uncharged metal sphere is placed near a larger negatively charged sphere. Which diagram best represents the charge distribution on the smaller sphere? Okay, so we can eliminate two choices automatically. B and D can be eliminated. The reason why is because it says it's a uncharged metal sphere, a small uncharged. D is all negative. This is not uncharged. And B also, even though it's uncharged, meaning it's neutral, the charge configuration when brought near a large charge object like this will polarize, right? Polarized charges, meaning you're going to have a clear, distinct positive side and negative side. So that's why B is eliminated. The only one that makes sense is C, because negatives want to attract positives and vice versa. Positives and negatives want to attract. So the positives will align on this side towards the negatives. All right. Next, number 11, it says a charged electroscope can detect. An electroscope is used to detect both positive and negative charges. So that's C. Okay. Remember, an electroscope, they can be negatives, they can be positives, or they can be stuff like this. Okay. So both positive and negative charges. Number 12 says, I don't know if you guys can see these numbers. They're a little, I can barely see them. It says a particle could have a charge of what? Well, on our reference table, we see the charge of an elementary particle is 1.6 times 10 to the negative 19 coulombs. We don't need this exponent part. This is unnecessary. We just need to look at the coefficient. This coefficient needs to be for an allowed charge for a particle to have, it needs to be a multiple of 1.6. Multiple of 1.6. So the only number up here that is a multiple of 1.6 is C, which is 3.2 times 10 to the negative 19 coulombs. Okay, 0.8 is not a multiple, that's a factor. 1.2 is not a multiple or a factor, and 4.1 is not a multiple or a factor. So the answer is C. For 13, it says two metal spheres have charges of positive 4 times 10 to the negative 6 coulomb and 2 times 10 to the negative 5 coulomb, respectively, are brought into contact and then separated. After the separation, the charge on each sphere is what? Okay, so when two metal spheres are brought together, touched, and then separated, they're going to share the same charge. So we need to figure out the average between 4 times 10 to the negative 6 coulombs and 2 times 10 to the negative 5 coulombs. Okay, these are both positive. So 4 plus 2 is 6. And then if you're going to divide that by 2, because it's 2 spheres, you get 3 times 10 to the negative 5. Uh, um, oh, whoops, this is negative 6 and this is negative 5. So what I actually have to use a calculator. My bad. I can't do what I was just doing. I actually have to use a calculator. So when you plug that into your calculator, let me just do this in Google. 4 negative 6 plus 2 5. And then when we divide this by 2, you get this answer, D. Okay, so the average of these two is you get 0.000012, which is 1.2 times 10 to the negative 5 coulombs. Okay, so to figure this out, you're averaging the charges if they're touched and then separated. Okay, next, thanks Alexandria. Next, number 14 says, which diagram represents the electric field lines between two small electrically charged spheres? Something you need to remember. This is definitely something you need to memorize. For positive charges, they come out, and for negative charges, they go in. Okay, this is always true. So the only one that's true, the only one that's correct is B. All right, it has positive charges coming out from both positive charges. Here, for choice A, you have a positive going into a positive. Wrong. For choice C, you have a negative going into a positive. That's wrong. And then for part D, you have positives and negatives both having the electric field lines coming out. So that's wrong. Number 15 says a beam of electrons is directed into the electric field between two oppositely charged parallel plates as shown in the diagram below. The electrostatic force on the electrons by the electric field is directed where? So we have electron beams. Electron beams are basically just individual electrons. Okay, so you have an electron and it's being shot towards this way. The electron wants to repel from this negative side, so it's going to go towards the top of the page. Okay. Number 16, it says a 3 times 10 to the negative coulomb test charge is placed near a negatively charged sphere. The sphere exerts an electrostatic force of magnitude 6 times 10 to the negative 5 newtons on the test charge. What is the magnitude and the direction of the electric field strength at this location? Electric field strength, I forget what that is, but I have to go on my reference table on page 4 of the reference table. Electric field strength is E equals the electrostatic force divided by your test charge. My electrostatic force is given by 6 times 10 to the negative 5 newtons, and my test charge is 3 times 10 to the negative 9 coulombs. So when I do this, I'm going to get 6 divided by 3 is 2 times 10 to the negative to the positive 4. Okay, newtons per coulomb. So now it's to figure out, is it away from the sphere or towards the sphere? Well, it's a test charges are always positive. Okay, test charges, that's the trick to the question. Test charges are always positive. Okay, Nick, I will go back to number 8 in a minute. So test charges are always positive. So if it's brought near a negatively charged sphere, that means it's going to be directed towards the charge. So that's part B. So Nick, let me go back to question 8 so that I got it wrong. 8 says, oh, this pendulum one. The statement is true about the swinging pendulum. I spent a good couple minutes and found 4 sides telling me it was D, not A for that one. The potential energy at A equals the kinetic energy at B. Okay, I'm gonna have to come back to this. Because I don't want to spend too much time on something I may have gotten wrong. So I'll come back to it, I promise. Let me just try to continue the rest of these problems. Number 17. What is the magnitude of the electrostatic force between 2 electrons separated by a distance of 1 times 10 to the negative 8 meter? This is an easy one. This is Fe equals K times Q1, Q2 over R squared. K is the electrostatic constant. That's on the reference table. It has a value of 8.99. 8.99 times 10 to the 9 Newton meters squared per coulomb squared. 2 electrons. So the charges of 2 electrons is 1.6 times 10 to the negative 19 coulombs. And I'm just going to square this because this is 2 electrons. And the distance is 1 times 10 to the negative 8 meters. This is also squared. Don't forget to square the denominator. Students definitely sometimes forget to square that denominator. So we're going to get 8.99 times 1.6 times 1.6. And so I get a value of 2.3 times 10 to the negative 12. Let me just make sure that's right. 19 plus 19. $16. Yeah, okay, that's right. All right, next, 18. This says the current in a wire, so current equals 4 amperes. The time required for that many electrons. So it has electrons equals 2.5 times 10 to the 19 electrons to pass a certain point in the wire is, we're solving for time. Okay, so the formula we need to use is I equals Q over T, charge over time. We need to convert these elementary charges into coulombs. And the way we do that is just by multiplying by 1.6 times 10 to the negative 19. So 2.5 times 1.6 equals 4 coulombs. Okay, so solving for time, we get charge over current, which is 4 coulombs divided by 4 amperes, which equals 1 second. So the answer is A. For number 19, the resistance of a circuit remains constant. Which graph best represents the relationship between the current in the circuit and the potential difference provided by the battery? So it says resistance is constant. We also have relationship between the current, so I, and the potential difference. Okay, this is an Ohm's law problem. So V equals IR, and our X and Y variables are potential differences on the X, and our Y is our current. So that means we need to solve for I, current. So I equals V over R. R is constant, so how does I change as the potential difference changes? Well, they're directly proportional. So that answer is D. Okay. For number 20, it says at 20 degrees Celsius, 4 conducting wires made of different materials have the same length and the same diameter. Which wire has the least resistance? This is a problem you cannot solve without your reference table. So you need to go on to page 4 and look at those different resistivities. The formula for resistance is R equals rho times the length of the wire divided by the area. If they all have the same length and they all have the same diameter, that means length and the diameter and the area are constant. So that means that resistance is directly proportional to the resistivity, rho. So we just need to figure out the least resistance. We need to figure out the least resistivity. So if we look at aluminum has a value of 2.82. Gold, which is AU, I think. Gold has 2.44. Nichrome has a value of 150, and tungsten has a value of 5.6. So the lowest one here is gold, least resistance, because of the least resistivity. Okay. For number 21, it says a 9-volt battery is connected to a 4-ohm resistor and a 5-ohm resistor as shown in the diagram below. This is a series circuit. What is the current in the 5-ohm resistor? So if I look at my reference table, since this is a series circuit, the current is shared throughout the whole thing. So if I can figure out the current for any of these values, I'll figure out the current for the 5-ohm resistor. Okay, so current is given by Ohm's law as V over R. Okay, so I want to figure out the total resistance because the voltage or the potential difference in a series circuit is not the same. So I can't just simply do 9 divided by 5. Okay, that wouldn't be the correct answer. So I need to figure out the total resistance. So I'm going to use my total. Okay, and since I total equals I1 equals I2, so on and so on. So the V total is 9 volts. That's my voltage. And my total resistance is 4 ohms plus 5 ohms, which is 9 ohms. This equals 1 ampere. So the answer is A. If I would have done 9 divided by 5, I would have gotten 1.8, which is an answer there, but it's the wrong answer. Okay, next. For number 22, which circuit has the smallest equivalent resistance? Okay, smallest equivalent resistance. Equivalent resistance in a series circuit equals R1 plus R2 and so on and so on. So let's forget the series circuit first, okay? This one equals 4 ohms. This one is also, D is also a series circuit. That's 2 plus 2 plus 2 plus 2. 2 times 4 is 8. So obviously it's not going to be D. We can also eliminate A, okay, because it only has 2 resistors here. 1 over 2 plus 1 over 2 equals 1/2. I mean, equals 1, and then 1 over 1 equals 1. We're going to eliminate that, though, because I just know that's not the right answer. All right? And since this was 1, this also can get eliminated, 4, since 4 is greater than 1. That leaves C, okay? Usually in these problems with the smallest equivalent resistance, it's almost always a parallel circuit, okay? And as you add more resistors in parallel, it actually decreases the overall resistance. This overall resistance here is much less than 1 ohm. All right? This is 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2, which equals 2. And then the inverse of this equals 1/2. Okay? So this one is the answer, C. For number 23, which diagram below correctly shows currents traveling near junction P in an electric circuit? Okay, again, we can eliminate one of them right off the bat. B could be eliminated because we have all three circuits, all three currents going into the junction. This is going in, this is going in, this is going in. There's no out. So that has to be eliminated. This one actually can't exist. Now we need to know that the current going in equals the current coming out. So this is 3 going in, and this is 7 going in. So that's 10 going in. And that does not equal 10 going out. Okay? So A is not correct. C is 7 going in and 4 going in. 7 going in and 4 going in. So this is 11 in, and that's does not equal 11 out. Okay. For this one, we have 7 going in and 3 plus 4 going out. So this is correct. The answer is D. All right. So for a question like number 23, the rule you guys need to remember is the current going in equals the current going out. In and out, I mean by into the junction at point P or out of the junction at point P. All right. For number 24, it says in the circuit diagram below, 2 4-ohm resistors are connected to a 16-volt battery as shown. The rate at which electrical energy is expended in this circuit is what? So electrical energy expended, the rate at which electrical energy is expended. This is power. This is what we're solving for. And we know it's power because of our units for our answers, which is watts. So if I look on the reference table, I'm on page 4, power is P equals voltage times the current. That's also equal to current squared times the resistance. And that's also equal to potential difference squared over R. Okay, so I'm given total voltage, V equals 16 volts, and I'm given my total resistance, which is 4 plus 4. It's a series circuit. This is 8 ohms. So the formula I'm going to use is this one right here, right? So 16 squared over 8. I don't know 16 squared off the top of my head. So that's 256 divided by 8, which is 32 watts. So the answer is C. Okay. Number 25. The total amount of electrical energy used by a 315-watt television during 30 minutes of operation is what? Total amount of electrical energy used. So we're solving for energy or work, electrical energy. We know that the power for the television is 315 watts, and we know time is 30 minutes. In order to use the formulas on the reference table, time needs to be in seconds. So to convert this to seconds, we just multiply 30 minutes times 60 seconds per minute. And we get 1800 seconds. Okay? So now we need to figure out what our formula is on the reference table. Well, on the reference table, power and work are given by this whoops, excuse me. Power and work are related using this formula. This is also on page 4. So we're just going to plug in our values. 315 times 1800, and we get 315 times 1800. We get 567,000 joules. Okay, that would be choice A. Choice A is 5.67 times 10 to the 5. This is 5.67. I can barely see these joules. Okay, number 26. If a 1.5 volt cell is to be completely recharged, each electron must be supplied with a minimum energy of what? So voltage is 1.5 volts. Each electron supplied. So electron equals 1.6 times 10 to the negative 19 coulombs. It's asking for energy. What is the minimum energy? Okay, back to our reference table. On our reference table, we have voltage equals work over charge. Okay, so if our voltage, we're solving for work or energy, so we're going to do work equals potential difference or voltage times charge. Our potential difference is 1.5, and the electron, even though it also equals 1.6 times 10 to the negative 19 coulombs, it also equals 1 elementary charge. So if we multiply 1.5 volts times 1 elementary charge, we get 1.5 electron volts. So this is our answer, A. Okay, next, 27. I guess we're moving on to waves now. The diagram below represents a transverse water wave propagating towards the left. A cork is floating on the water's surface at point P. In which direction will the cork move as the wave passes point P? Okay, so the way to do this is you need to kind of see, as the wave is moving this way, right? It's moving to the left. This whole wave function, this wave shape, is also going to be moving towards the left. So this cork is going to go down, right? It's going to go down this way, and then it's going to go up, right, until it reaches this point, and then it's going to go down again, right? It's a transverse wave. So we know that we can eliminate C and D because they're talking about them moving left and right. The wave is already moving to the left. So transverse waves has perpendicular direction. So the answer is B. Down, then up, then down. Okay? Moving on. Number 28 says transverse waves are to radio waves as longitudinal waves are to sound waves. Light, ultraviolet, and microwaves, they're actually all forms of light. So A, B, and C are basically saying the same thing. D is the only difference. Transverse waves are light waves, like radio waves, and longitudinal waves are sound waves. Okay? Next. 29 says, a physics student takes her pulse and determines that her heart beats periodically 60 times in 60 seconds. The period of her heartbeat is what? So period is measured in seconds. So this is the time divided by the number of oscillations. Okay? So we have 60 seconds over 60 times, which is 1 second. Okay? So period is 1 second. Notice they put hertz here to confuse you, right? Hertz is frequency. So seconds equals period, hertz equals frequency. Okay. Number 30, sound waves are produced by a horn of a truck that is approaching a stationary observer. Compared to the sound waves detected by the driver of the truck, the sound waves detected by the observer have a greater what? Okay, I like to draw a picture for this. So if this is the stationary observer, here is the truck going this way, right? What's going to happen is the sound waves are going to, if it's moving in that direction, the sound waves in that same direction are going to get bunched together, okay? They're going to get closer and closer together. They're basically getting squished together. So this is actually increasing the frequency. So the answer is B here. All right. The speed of the sound waves don't change, and the period and the wavelength actually decreases. The wavelength here, if this is lambda, look at the wavelength from here compared to the wavelength here, which is less. Okay. So the wavelength is decreasing, therefore the frequency must be increasing. This is a Doppler effect question. Okay, let's move on to the next one. 31, the diagram below represents a standing wave. The number of nodes and antinodes shown in the diagram is what? Okay, for nodes, the way I like to think about it, nodes means no. So no amplitude. The areas with no amplitude. 1, 2, 3, 4, 5, 6. 6 nodes. So that eliminates A and B. So there's 6 nodes. For the antinodes, we're either going to count, let's always count the solid line for the antinodes. Antinodes, anti-no, means the opposite of no amplitude. So the highest amplitude, actually. So we have 1, 2, 3, 4, 5. Okay, 5 antinodes. The rule is there's always one less antinode than the node. Okay, so for antinodes equals nodes minus 1. Always true. There's no exception. So the answer here is C. For number 32, compared to the speed of a sound wave in air, the speed of a radio wave in air. So the speed of sound wave in air, V for air and for sound. On the reference table, it tells you 331 meters per second, and the speed for a radio wave is light is much bigger at 3 times 10 to the 8 meters per second. Okay, this is 300 million meters per second. So therefore, the speed of a light wave is greater, much bigger, much bigger. 33 says, what is the wavelength of X-rays with a frequency of that traveling in a vacuum? Okay, so we have frequency equals 1.5 times 10 to the 18 hertz. It says it's the wavelength is what we're solving for. And it says it's an X-ray. An X-ray is light, so it's traveling at the speed of light. So 3 times 10 to the 8 meters per second. The formula is the wave equation. V equals lambda times the frequency. Is that correct? I always forget. Yeah. So solving for lambda, we get V over the frequency, which is 3 times 10 to the 8 over 1.5 times 10 to the 18. And we get 3 divided by 1.5, get 2. times 10 to the negative 18 meters. Okay, that's the answer. Next, which waves can be polarized? The only waves that can be polarized are light waves. Okay, sound waves cannot be polarized. Longitudinal waves are sound waves, and seismic waves, which are primary earthquake waves, those cannot be polarized. Those cannot be uh, the direction, the orientation of the waves cannot be changed. So polarized, only light. Okay. Which color of light has a wavelength of 5 times 10 to the negative 7 meter in air? Okay, so we have wavelength equals 5 times 10 to the negative 7 meters. It's the speed of light, so this is 3 times 10 to the 18, oh, sorry, 3 times 10 to the 8 meters per second. We actually don't need this. I'm dragging it. All we need to do is actually look at the reference table, page 2, electromagnetic spectrum, and we look for this wavelength on the electromagnetic spectrum. Okay, so 5 times 10 to the negative 7 for wavelength. Oh no, you do. What am I doing? You do need to use this. So we need to solve for frequency, right? Because if we look on the electromagnetic spectrum, the different frequencies for the different lights, like violet, blue, orange, they're in frequencies. So we're going to use this equation from the from the last one. So that's frequency equals V over lambda. That's 3 times 10 to the 8 divided by 5 times 10 to the negative 7. 3 divided by 5 equals 6 times 10 to the 14 hertz. So looking on the reference table, page 4, we're looking for 6 times 10 to the 14. The one that's closest is somewhere between blue and green. So if we look at 6.10, it's actually closer to the green one. So this is green light. Blue light actually has 6.59. Okay, green light is 6.10. Moving on. Number 36. What happens to the frequency and the speed of an electromagnetic wave as it passes from air into glass? Okay. Okay, so hold on. Before I move on, do I need to clarify number 35? Okay, so when we want to figure out what type of color, what specific wave we want to look at, you want to use usually the wavelength and the frequency together. So if we looked at the wavelength, if we looked at the wavelength only, that would be times 10 to the negative 7. Times 10 to the negative 7 would be ultraviolet, right? However, if we determine the frequency is, when we use this wave equation, the frequency is 6 times 10 to the 14 hertz. If we look at the electromagnetic spectrum, 6 times 10 to the 14 is closest to 6.10 to the 14, and that would be green light. Okay? The way that it's set up is that the numbers are kind of to the left of the color. Okay. All right, let me move on to number 36. What happens to the frequency and the speed of an electromagnetic wave as it passes from air into glass? So first, the frequency of any electromagnetic wave has to stay the same. So A and B are wrong. Okay. Next, we're going from air to glass. Air is where the speed of light is the fastest. All right, it's the fastest. So if it goes into glass, then it has to decrease. So by process of elimination, it's D. Okay. For 37, which will most likely occur when light passes through a double slit? Here's this word double slit. So if we have a double slit, okay, here's my double slit. That's slit 1, slit 2. As the wave is passing through, let me redraw these waves with a different color. As the waves are passing through, what's going to happen is it's going to bend, right? And it's going to what's called diffract. At the same time, it's also going to cause interference. Interference is when two waves kind of overlap on each other, okay? So it's causing interference and diffraction. Okay, this is that video that I showed in class with the double slit experiment with, what's his name, Dr. Quantum. Number 38. The diagram below represents a light ray reflecting from a plane mirror. The angle of reflection for the light ray is blank. Okay, this is a very tough question actually, because it gives you the angle here, 65 degrees. And in the reference table, you have angle of incidence equals angle of reflection. So just by looking at the 65 degrees, you automatically think that the answer was D, right? No, wrong. This is not the correct answer. 65 degrees is not the correct answer. That's because the angle of incidence and the angle of reflection is always measured to the normal line. It's always measured to a normal line. Okay, so this right here is our normal line. You actually never measured the angle towards the material. Okay, this 65 degrees here is there to kind of trick you. Say like, oh well, this is 65 degrees and this has to be 65 degrees. This is 65 degrees. That is true. However, we need to figure out this angle. This is the angle we need to figure out. That's theta of our reflection. Okay, and since this is a 90-degree angle, if this is 65, then this has to be 25 degrees. So the answer actually is A, 25 degrees. Okay, so on the Regents, please be careful when you're determining these angles. The angle is always measured to the normal line. Angles are always measured to the normal line. Okay. Next, 39. What is the speed of light in ethyl alcohol? So what we're going to do is on a reference table, we're going to use this formula. Formula is N equals C over V. Okay. Ethyl alcohol has a value on the reference table. That's on page 2. Ethyl alcohol has an absolute index of refraction of 1.36. So this is 1.36 equals the speed of light, 3 times 10 to the 8 meters per second, over its new speed. Okay, so the new speed is just 3 divided by 1.6. So that is 3 divided by 1.36, and you get 2.2 times 10 to the 8 meters per second. Closest answer is D. All right. Shiza, the question you asked, even if we aren't given a normal line, would we have to draw it? Yes. And the normal line is always perpendicular, perpendicular to the surface. Okay. They don't always give it, because number 38 is an example where they don't give you the normal line. But that's an old question. New questions now, I think they always give you the normal line. Okay, for number 40, here's a magnetism question. Which statement describes the polarity of magnetic poles A and B? Okay, so if we're talking about a pole, here's the North Pole, here's the South Pole. The magnetic field lines always come out of the north into the south. Out of the north into the south. This is always true, okay? So the only one that makes sense, since the lines are coming out of A and into B, the only one that makes sense is A. The A is the North Pole and B is the South Pole. Okay. Moving on, 41. An electron in a mercury atom drops from energy level F to energy level C by emitting a photon of having what energy? So we're in the mercury atom. So this is on page 3 of your reference table. So energy level F, that energy associated with it is 2.68 electron volts. And for energy level C, that electron level is 5.52 electron volts. So we're going to use this formula. Energy of a photon equals energy initial minus energy final. So energy initial, this is my initial, this is my initial, this is my final. So we're going from 2.68 minus 5.52, and we get 2.68 minus 5.52. We get an answer of 2.84 electron volts. This is the energy of the photon that is emitted when the electron jumps from F to C. Okay, so that's C. 42. 42 says a photon having an energy of 9.40 electron volts strikes a hydrogen atom in the ground state. Why is the photon not absorbed by the hydrogen atom? If we look on the reference table, for the ground state of hydrogen, it requires 13.6 electron volts. The photon that it's trying to get absorbed is 9.40 electron volts. So the answer here is that C, the photon's energy is too small. All the other ones are not true. C is the only one that's true. Okay, it doesn't matter how fast the atom is moving. The photon can absorb it as the atom can absorb the photon as long as it has that right number. Okay, remember, energy needs to be quantized. Okay, so this is the only number that'll accept. For number 43, the composition of a meson with a charge of -1 elementary charge would be what? So I'm just going to rewrite this because I can't see this. This is strange, anti-charm, down, strange, strange, up, anti-bottom, and anti-up, anti-charm, anti-down. For a meson, according to page 3 of your reference table, a meson needs a quark plus an antiquark. Oops, antiquark. So the choices that are eliminated are D and B, right? So we don't need this, we don't need this. So it's either strange and anti-charm or up and anti-bottom. So now we just need to figure out which one is equal to -1. The charge needs to be -1 elementary charges. So a strange quark has a value of negative 1/3, and an anti-charm has a value of negative 2/3. This equals negative 3/3, which equals negative 1 elementary charges. So this is for strange and anti-charm. Okay, so the answer is A. Number 44 says, experiments performed with light indicate that light exhibits, it's always both wave and particle properties. Okay. Next, 45. A tritium nucleus is formed by combining 2 neutrons and a proton. The mass of this nucleus is 9.106 times 10 to the negative 3 universal mass units, less than the combined mass of the particles from which it was formed. Approximately how much energy is released? Okay. Usually you want to use E equals mc squared to convert mass into energy and vice versa. But if they give you, this is the trick, if they give you universal mass units, you can directly convert mass into energy using a conversion factor on the reference table. On page 1, you'll see that 1 universal mass unit equals 931 mega electron volts. And if we set up a ratio, or we just set up a simple conversion, we'll get that 9.106 times 10 to the negative 3 universal mass units equals 8.48 mega electron volts. Okay? Number 46 says, what is the minimum total energy released when an electron and its antiparticle, the positron, annihilate each other? Here's the type of problem where you use E equals mc squared. Okay, so we're trying to figure out the energy released. So we're using the mass of an electron. The mass of the electron on the reference table is on page 1. Mass of the electron is 9.11 times 10 to the negative 31 kilograms. Okay, and the mass of the anti-electron is also 9.11 times 10 to the negative 31 kilograms. Okay, antiparticles have the same mass as their counterpart particles. The only difference between a particle and an antiparticle is that they have opposite charges. Okay, so we're going to figure this out. We're going to figure out the energy released for the electron. And when we plug in these values, we get 9.11 times 10 to the negative 31 times the speed of light. C is the speed of light squared, so 3 times 10 to the 8 meters per second squared. And that value, let's see what we get in the calculator. We get 9.11 times 10 to the negative 31 times 3 times 10 to the 8 squared. So this value here, we get E equals 8.199 times 10 to the negative 14 joules. This is an answer here. Choice B is the answer for that, but that's just for the electron. We also need to figure out the energy required for the positron. Since it's the same mass, we just do 2 times this, and we're going to get 1.64. Okay, so we multiply this by 2 because it's the energy of the electron plus the energy of the positron. So that answer is 2. Okay. That answer is 1.6. Okay. So this is the short answer questions. A roller coaster car has a mass of 290 kilograms. Starting from rest, the car acquires 3.13 times 10 to the 5 joules of kinetic energy as it descends to the bottom of the hill in 5.3 seconds. Calculate the speed of the roller coaster car at the bottom of the hill. Okay, so we have, I'm going to write out my variables. Mass equals 290 kilograms. we have it's starting from rest, so V equals 0 initially. The car has a kinetic energy, final kinetic energy of 3.13 times 10 to the 5 joules. And the time it takes is 5.3 seconds. Calculate the speed of the roller coaster at the bottom of the hill. Okay, so kinetic energy is given by 1/2 mass times velocity squared. All right. So if I want to figure out this, all I have to do is plug in my values here. Kinetic energy final equals 1/2 times mass times the velocity squared final. Okay, so my final kinetic energy is 3.13 times 10 to the 5 joules equals 1/2 times 290 kilograms times V squared. So what I'm going to do is I'm going to solve for V. So I have to take the square root. So 3.13 times 10 to the 5. If I take the square root of this, 2,158.62 equals approximately 46.4. So the final speed after I take the square root is approximately 46.5 meters per second, right? So that's the answer for number 47. For number 48, it says calculate the magnitude of the average acceleration of the roller coaster as it descends to the bottom of the hill. Show all work, blah, blah, blah. So acceleration equals V final minus V initial over time. V final is 46.5 meters per second. My initial speed was 0, and my time is 5.3 seconds. So 46 divided by 5.3 equals approximately 8.7 meters per second squared. So that's the answer for that. Next, 49, calculate the height of the hill. Neglect friction, show all work, blah, 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 blah. So the height of the hill, the only way to figure this out, figure out the height, is actually there's a few ways actually. We can figure out the potential energy. mgh equals mgh. Okay, so if we could figure out the kinetic energy at the top of the hill, we could figure out the potential energy at the top of the hill. Since this is a roller coaster, right? All of the potential energy here gets converted to the kinetic energy here. So we can actually do this. Kinetic energy equals mgh. This is the final kinetic energy. Our final kinetic energy was 3.13. So that's 3.13 times 10 to the 5 equals the mass of the cart times 9.81 times the height. And when we plug that in, let's see what we get. Divided by 290. 290 divided by 0.81. So we get a height of 110 meters. Okay. The other way you guys could solve this problem is by using the kinematics equation on the back of the reference table, like D equals VIT plus 1/2 AT squared. You plug in the time, you plug in the acceleration, and you'd be able to figure that out. Okay. All right. Alexandra, your question, wouldn't they take points off for boxing your answers? No, they don't take points off for boxing your answers. Actually, there's usually an answer space provided in a lot of the questions. Boxing your answers just identifies your answer. Okay? Okay, so number 50. 50 says, an electric circuit contains a source of potential difference and 5 ohm resistors that combine to give the circuit an equivalent resistance of 15 ohms. Draw a diagram of this circuit using circuit symbols from the reference table. Assume the availability of any number of 5 ohm resistors and wires of negligible resistance. So they need an equivalent resistance of 15 ohms. R equivalent equals 15. If we build a series circuit using only 5 ohm resistors, we need 3 5 ohm resistors. 5 ohm plus 5 ohm plus 5 ohm equals 15 ohms. Okay, so we're going to draw a series circuit. We have some voltage source, some potential difference, and we have, here's my first ohm resistor, second ohm resistor, and my third 5 ohm resistor. Okay, so this is one way to draw the circuit. You could have easily drawn the circuit like this as well. 1, 2, 3, and 5 ohms, 5 ohms, 5 ohms. It's easier to do this with a series circuit. I don't think it's possible to build a parallel circuit using 5 ohm resistors to get 15 ohms. Okay. Okay, so for the next one, need a protractor. I don't have a protractor, so I'm gonna again do some estimations. So for 51, it says a ray of light is incident on the boundary between air and an unknown material, X, at an angle of incidence of 55 degrees as shown. The absolute index of refraction of material X is 1.66. Calculate the angle of refraction of the ray of light on material X. So, angle of refraction, we use this formula. N1 sine theta 1 equals N2 sine theta 2. Okay, so N1 is air, so that's 1. Sine theta is 55 degrees. N2 is 1.66, and we're solving for sine theta 2. So in order to figure this out, we need to do and we're going to divide this by 1.66. So basically, on my left side, I get 0.49 equals sine theta 2. So now I need to do sine inverse or arc sine. Okay, so that would be of what's my value? 0.49. Yikes, I need to fix my calculator. Okay, so the answer we get is approximately 30 degrees. Okay, or 28. Doesn't really matter. Okay, so on the Regents, you're given like a few errors. So the answer I get is 30 degrees, or 29.6. Okay, sorry, not 20, not 28. It's 39.6. 29, sorry, 29.6 or 30 degrees. So I'm going to round it up to 30 degrees because that's easier for me to plug in or draw. Okay, it's difficult to draw a 29-degree angle, but 30-degree angle is easy. So for number 52, it says on the diagram above, use a straight edge and protractor to draw the refracted ray of light. So you would use a protractor, okay, protractor, and you're going to draw your refracted angle. Remember, it needs to be measured from the normal line. This is our normal line here, and the refracted angle is going to be somewhere along this way, okay? So that means that this angle here is 30 degrees between the dotted line and your refracted ray. That's what 30 degrees is, or 29.34, as Anissa said. The next question says, wait, did I skip a question? Oh, next question says, determine the speed of the rate of light in material X. I think also if you needed to draw the reflected angle, right, this would be 55 degrees. Here's your theta reflected, okay, 55 degrees. So it says determine the speed of this light ray in the material X. So we need to figure out the speed. Okay, well, it's coming in from air, so the speed is 3 times 10 to the 8 meters per second. Our what's it called? Index of refraction was 1.66. So we need to figure out the speed after that. So the speed after that is 3 times 10 to the 8 meters per second divided by 1.66. This formula is on your reference table. N equals C over V on your reference table. So 3 divided by 1.66, and we get a value of 1.8 times 10 to the 8 meters per second. Okay, so that's 53. All right. I think these are the last two questions. This is based on some reading passage. I honestly don't know if you guys are going to get a little reading passage to read. They kind of stopped doing that. But this passage basically says how the aurora borealis are formed, okay? And it's a modern physics passage, so it involves stuff about energy levels and states. I'm not going to read it, but number 54 says, explain what is meant by an atom being in its ground state, okay? So if you actually read the problem, it says from the lowest available energy level, the ground state. That's it. That's the only thing you need to write down. So explain what is meant by the atom being in its ground state. It is the lowest possible energy level. Okay? Lowest available energy level, the ground state. Okay, and for number 55 says, calculate the energy of a photon in joules that accounts for the red glow of the aurora. Show all work. So the energy of a photon equals E initial minus E final. And we need to go back to the reading passage, and the reading passage says what do we say here? Most return to in their higher energy levels. A few these atoms account with the clearance of red glows. As these oxygen atoms return to their ground state, they emit green photons and red photons. These emissions last long enough to produce the changing aurora. Okay. So actually, I don't think we need to. I don't think we need to actually use this that formula. Okay, so the formula that I actually do have to use is the other formula, not this one. The energy of a photon equals Planck's constant times the frequency, and it also equals hc over lambda. Okay, so we're just going to use this one. The energy of a photon equals Planck's constant times the frequency. So we're talking about for the red glow. So that would be 6.63 times 10 to the negative 34 joule seconds times the frequency given in that problem for red. The frequency given for red is 4.76. 4.76 times 10 to the 14 hertz. And this value that we get is 6.63 times 4.76. So the value we get is approximately 3.16 times 10 to the negative 19 joules. Seconds and hertz, they're opposite units, so they cancel out. So we're left with joules. Okay. Shai's, who asked this question? Alicia Park. Who the hell is that? It says, if you write that it is not excited, would it be wrong? Yes, you would be marked wrong. Okay, you need to mention something along the lines of that the energy, the ground state is the lowest possible energy level, or according to the passage, the lowest available energy level. Okay, thank you, Alexandria, for the formula. That is all the questions I have. If you guys have any questions, you can ask them. Otherwise, I need to go. Yeah, question number 8. Forgot about that, Nick. Okay, thanks, guys. Okay, so it says the potential energy at A equals the kinetic energy at B. You know, Nick, to be honest, I'm not entirely sure about this one, but it might be all the stuff that I was saying before. It might be that just wrong, but this part here, part B, point B is the equilibrium point. So this is actually where the kinetic energy and the potential energy exchange. That's actually when they convert, where KE and potential energy exchange. So that might be why D is the correct answer. Okay. Any other questions?